Grace and peace to you, and welcome back to my second video on approximations. This is Donald Siame, author of Hidden Mathematical Genius Within Revealed. Question 1. In a practical examination, Nelly recorded the volume V of water as 6.4 liters, correct to 1 decimal place. Complete the statement in the answer space below. So here we can see we have dash less or equal to V less or equal to. So here we need to have an interval, and an interval should be from the lowest to the highest. So we need to have the least, we need to have the lower bound and the upper bound. Okay, so you know that for us to know the lower bound and upper bound, we need first to know the absolute error. Okay, so our measured value is 6.4. It is in 1 decimal place, and we know that if we have 1 decimal place, the least unit of measurement is 0.1. So absolute error is equal to least unit of measurement divided by 2. Okay, we have a 1 decimal place number, so the least unit of measurement is 0.1. So 0.1 divided by 2, that will be our absolute error. So 2 in 0 is 0 point, 2 in 1 is also 0, then the remainder will be 1, so you add the 0 to 1, and 2 in 10 is 5. So the absolute error is 0.05. Okay, so we need to know the lower limit or lower bound, and also upper limit or upper bound. So lower limit is equal to our measured value. Our measured value in this case is 6.4 liters minus the absolute error is 0.05 liters. Okay, so what is 6.4 minus 0.05? Okay, so we say 6.4 minus 0.05. 0.05. So there we have a 0. We get a 1 from there, remain with 3. 10 minus 5, that is 5. 3 minus 0 is 3. 0.6 minus 0 is 6. So the lower bound or lower limit is 6.35 liters. We go to upper bound or upper limit. So upper limit is equal to the measured value 6.4, then plus. So for upper limit you add absolute error. Lower limit you subtract. So 6.4 plus 0.05. So here you get 6.4 plus 0.05. You get 6.45 liters. So to complete the statement, we'll start with the lower limit is 6.35. So we have 6.35 less or equal to V less or equal to the upper limit is 6.45. So that is how we're supposed to complete the statement. We go to the second question. The actual length of the longest side of a rectangular playing field is 102 meters. A boy measured the same side as 99.8 meters. Calculate the relative error. So for us to calculate the relative error, first we need to know absolute error. Now in this case we have two values. We know the actual value, which is the true value, supposed to be 102 meters, and the measured value, the recorded value, that is 99.8. So we'll say absolute error is equal to the absolutes, that is true value 102 minus recorded value, in this case 99.8. So we have 102 minus 99.8. So there we have 0.0. So 0 minus 8, we get 1 from 2, remain with 1. There it will be 10. 10 minus 8, that is 2 point. Again we get a 1 from 10, there remain with 9. So we have 11. 11 minus 9, we get 2. That is 0. So we have 2.2. So the absolute error is 2.2 meters. That is the absolute error. Now we are solving for relative error. Relative error. So therefore, relative error is equal to, we know that relative error is equal to absolute error divided by a true value. So we have absolute error of 2.2 over the true value is 102. Okay, so we need to simplify that fraction. We have a decimal number on the numerator there. So first thing is to get rid of decimal places. So how many decimal places are there? Yes, we have one decimal place. So for one decimal place, we multiply by 10. So we multiply by 10 to both the numerator and the denominator. So what is 2.2 multiplied by 10? Yes, we get 22. And 102 multiplied by 10? Yes, we get 1020. Okay, the next is just to simplify the fraction. Okay, so we can see that 2 can go in 22 and 2 can go in 1020. So 2 in 22, you get 11 over 2 in 10, that is 5. 2 in 2, that is 1. And 2 in 0, that is 0. So you get 11 over 510. So this is how you perform calculations to do with approximations, particularly lower and upper limits and relative error. Thank you so much for your time.